Welcome to Bungalows for Bachelors yet again. Low duration factors. What does that mean? Well, the short good news is that you really don't have to worry too much about what it actually means, but what you need to know is that it's a thing and that it exists. So, what does it mean? Well, the basic premise is that we're designing houses out of wood, and wood is actually a time dependent material. If I were to take a piece of wood, let's say it's a beam situation. We always got a wall, we always got a beam here. So if I have a situation where I'm going to put some load in the center of this beam, then the strength of the beam and the deflection of the beam are calculated with a factor given towards how long the loads will be placed there. So if I have the same situation over here, let me try to summarize it by doing this here. So I have another wall over here, another beam over here, same dimensions, same everything, even though it doesn't look the same. Same load, and I have this for 1 day, and I have this for 10 years. The wood is going to be, it's going to perform differently. What's going to happen is it's going to start to actually be weaker when you consider like a long-term permanent load. And that's just because wood can handle much higher weights for short periods of time if the weights are removed, and it's fine. But if you leave the super heavy weights over long periods of time, then you end up with bad sag problems. This was an example of this is if you drive around older, built in the 70s and 80s tract home subdivisions, you will often see a double garage door, like a 16-foot wide garage door header. They frequently were using pretty much the minimum header size they could to get away with it. And now all of their headers sag like this, and if there's brick, there's like cracks going up the brick, and there's all kinds of problem with that. So these are problems when you don't design for long term loads. So the basic premise is that wood is a time dependent material in terms of its strength. So what does that mean for us? Well, there are equations that allow us to factor loads by the type of load. So I was talking in a previous video about the ceiling weights. So there's 5 pounds per square foot dead load and 10 pounds per square foot live load. So depending on, and this is all written out in the rules of wood design, depending on what member of the house you are designing for, what member you're doing the math for, you will have different load duration factors, which is what they're called. The basic premise of this would be, and I'm going to make up some numbers here, is I know that the 5 pounds per square foot of dead load is going to matter more because it's a permanent load. It's always going to be there theoretically on this member we're designing. The 10 pounds per square foot of live load means we're expecting a maximum 10 pounds per square foot, but it's going to fluctuate below that. It's not always going to be there. Like if you have like a 40 pounds per square foot live load of a floor or something, and you move in a piano, it can hold the piano, but if you move the piano out to a different house and there's no longer a piano, and the weight's not there anymore. So if we were to write an equation or something and we were to factor these, we would say something like total load equals, pick a number. Well, we'll leave it as 1 times 5 pounds per square foot dead load because the dead load is going to have a larger impact. So we're going to leave that load number where it is. And then we're going to add to it the live load. But the live load is less important over time. So we're going to make it like, let's say, 0.8 times 10 PSF. Now, you're not going to have to do any equations when we're doing any of this stuff because it's all calculated for us. And all these factors are already part of all the calculating processes in the software. So we don't need to worry about this. But you should understand that this is what the software is doing. It's depending on what member you've selected to design and depending on, all your inputs, it's going to do all this factoring for you and it's going to understand that, okay, these are my standard loads I'm going to put in. I know I need to know that number and I need to know that number, the standards, right? But I'm going to put it in and it's going to basically tell me thing at the end. And it's going to give me an answer. And by the end, it's going to have factored these things. And at the end in the report, if you read the report, it tells you these loads have been factored per this requirement of load duration factors, yada, 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 yada. So it tells you what it does. Long story short is that you just need to know that this is happening. I'm not going to be a lot of heaviness here. It's just be aware that wood is a time-dependent material, unlike something like steel. Steel, if you put some weight on it and leave it alone and never moves or never cycles, it's going to hold the same weight over 1 day as over 100 years, assuming it doesn't corrode or anything. So wood is not the same way just because of the way it is.